So our next question is to determine how the dot product is related to the angle between two vectors. What did we say previously? A vector has both direction and magnitude, but no location. So we know that. And we also know about the length of the vector. We know that u dot u is the same thing as the length of u squared. But if I have two vectors, I want to determine something about the angle between them. So let's look at the following. Let's call this vector v. And let's call this vector u. And then we want to look at the angle between them, which we're going to call theta. And we have this tool of the dot product. Remember, we multiply the change in x components plus the change in y components, plus if it's there, the change in z components to get the dot product. But how can the dot product be related to the angle between those two vectors? That's the question we want to ask. Now, what is the third side of this triangle? So let's imagine we're putting in a third side here. We want to think about what that third side will be. So what is that? What's the name of that vector in terms of u and v? We have vector v here. We have vector u here. V plus something has to be the same thing as u. From here to here first, followed by there to there, has got to be the same as going there directly. So v plus something equals u. So let's call this question mark for now. And we're going to say vector v plus something equals vector u. Well, using basic rules of algebra, we can subtract vector v from both sides or add the opposite of v pointing that direction. If I add the opposite of v to both sides, I get the fact that that question mark here, this third side of this triangle, is simply going to be vector u minus vector v. So this third side is vector u minus vector v. But our question still stands, namely, how is the dot product related to the angle between them? Because again, a vector has direction, and the direction is kind of an important concept, and magnitude, also an important concept. But if I have two vectors, I'd like to determine that concept, that angle between them. How can I make some sense out of that? Well, let's remind ourselves of this fact. A vector dot producted with itself is the same thing as the length squared. So if I were to take u minus v dot u minus v, u minus v dot u minus v, so these are all vectors. In print, those would be bold typically. U minus v dot u minus v would have to be what? The length of u minus v squared. So we know that fact. Now, it's actually kind of nice in that the dot product works exactly the way you'd want it to in terms of distributive properties. So keeping that in mind, what could we say then? U minus v dot u minus v is u dot u minus u dot v minus v dot u minus minus plus v dot v. And that, of course, is the same as the length of u minus v squared. Well, what do we know? We know u dot u is the same as the length of u squared. U dot v and v dot u, in the case of R2, the dot product is commutative. That is not true for all vector spaces, but in the case of the sorts of vectors we're working with in this class, that will be the case. So u dot v and v dot u are essentially the same thing. So we'll go ahead and make that twice u dot v. Plus v dot v is, of course, the length of v squared. And that is the same as the magnitude of u minus v squared. All right, but what do we want to remember from previously studied concepts? You want to keep in mind the law of cosines. Do you recall the law of cosines? Let's think about that. If I have a triangle with 3 sides, what are we going to have? Call this B. Call this A. Call this C. And then we will call the angle between A and B theta. Oftentimes in trigonometry, you'd call it angle C. But I'm going to go ahead and call it theta here. And what do we remember from the law of cosines? What is that going to be? What do we have here? C squared, the length of C squared, is equal to what? Is equal to A squared plus B squared. So sort of like the start of the Pythagorean theorem. A squared plus B squared minus 2AB cosine theta. So again, C squared is A squared plus B squared minus 2AB cosine theta, theta the angle between side A and side B. So if we apply that to this, so let's think about this triangle that we have here. So the triangle we have here has 3 sides. Let's go ahead and write those down. If we're thinking about these as lengths, then this side is the length of V. This side is the length of U. And this side is the length of U minus V. So C squared would be the length of U minus V squared. Equals A squared, which in our case here is U squared, length of U squared. Plus B squared, which in our case is the length of V squared. Minus 2AB, so minus 2 length U, length V. Cosine theta, cos of the angle in between. Okay. So now what we see is that this length of U minus V squared equals all of this, and length of U minus V squared equals all of this. So what does that tell you? Can you see what the next argument is going to be here? U minus V squared equals all of this. U minus V squared equals all of this. Therefore, this piece has to equal this piece. So as we write that down, what does that give me? Where does that put me? Then I am at this left-hand side equals this right-hand side. Length of U squared minus 2 U dot V plus length of V squared equals length of U squared plus length of V squared minus 2 length of U, length of V, cosine theta. Well, isn't that nice? And you'll notice that I have length of U squared on both sides here, here. I have length of V squared on both sides here, here. So those would subtract out, which gives me my next line, which will be minus 2 U dot V equals minus 2 length U, length V, cosine theta. And I'm sure you can see the next step, which is going to tell us something about how the dot product, again, is related to the angle between the two vectors. So we have the dot product here, U dot V. We have the angle theta, the angle between those two vectors. So what then is our concluding statement? What are we going to say? Dividing out the -2, our next statement is to say that u dot v is simply going to be magnitude of u times the magnitude of v times the cosine of theta. So this is our second major fact that we've established. Our first major fact, of course, was that the magnitude of the vector squared is simply going to be the dot product with itself, is going to be u dot u. So we want to keep these ideas together as we build our concepts going forward.